Welcome back, everyone. Today we're tackling a really foundational concept in software architecture. In this explainer, our whole goal is to take the highly technical template method pattern and translate it into something that just intuitively makes sense. So whether you're seeing this pattern for the very first time or you're just looking to, really lock in that architectural knowledge, we're going to break this down using some clear, relatable concepts that will actually stick with you. Picture this scenario. And I guarantee this has given almost every developer a minor headache at some point. You've written this absolutely beautiful, complex algorithm. It works flawlessly. But then, a new requirement drops on your desk. You need to run that exact same algorithm again, but with just maybe one or two slight tweaks right in the middle of the process. So what do? Do you just copy and paste the entire block of code and change those two lines? We all know that leads straight to the ultimate developer nightmare, code duplication. Because right when you fix a bug in version A, you have to somehow remember to fix it in version B. It's fragile, it's messy, and honestly, it's exhausting. There absolutely has to be a better way to reuse a structure without copy-pasting the whole shebang.
Well, there is, and here's our roadmap for how we'll unpack it today. First, the poster template analogy. Then, abstract versus concrete classes. Next, framework applications and hooks. After that, we'll look at the Hollywood principle. And finally, we'll compare the template method versus strategy.
Okay, let's dive into this with Section 1, the poster template analogy. To really get this, let's step away from the code editor for a second and imagine we're inside a graphic design agency. Imagine this agency pumps out promotional posters all day long. Now, if they started from a completely blank canvas for every single client, they'd be wasting so much time. So what do? Instead? They create a master blueprint. This blueprint dictates that, hey, every poster gets a title at the top and massive image in the middle and some text at the bottom. The margins, the spacing, the overarching layout, that is their fixed algorithm. It literally never changes. But the specifics, those absolutely change. If a rock band hires them, that empty image slot gets filled with the band's photo. If a politician hires them, that exact same slot gets a campaign headshot. The agency has built a single blueprint where the overall sequence doesn't vary, but the specific delegated details are just swapped out depending on who the client is. And that analogy is basically a perfect match for the formal definition you'll find in the classic Gang of Four design patterns book. The template method defines the skeleton of an algorithm in an operation, deferring some steps to subclasses without changing the algorithm structure. Just like our graphic design agency, the invariant parts, the stuff that stays exactly the same, are locked right into the skeleton. The variant parts, the things that change, like the rock band or the politician, are deferred. You're never rewriting the blueprint, you're just filling in the blanks.
Moving on to Section 2. Abstract versus concrete classes. Let's take that physical poster concept and translate it into the actual object-oriented programming terms you'll be writing in your codebase.
It all starts with the abstract class. In software, your abstract class is that blank poster template. It holds the actual template method, which is just the function that calls all the steps in a very specific, fixed order. But here's the catch. Because it has missing pieces, those empty slots for the image or the text, it's incomplete. You literally cannot instantiate it directly. If you ask the program to just run the abstract class on its own, it would basically throw its hands up and say, "Run what? Half of this is missing." It absolutely requires a subclass to be complete.
And that brings us right to the concrete class. A concrete class inherits everything from that abstract class, but its specific job is to provide the actual code for those missing pieces. We often call these missing pieces primitive operations. Going back to our poster example, one concrete class might be music band poster, which supplies the band's photo. Another would be politician poster, supplying the campaign photo. The concrete classes are the workers actually filling in those blanks.
So, the absolutely crucial takeaway here is this separation of duties. The abstract class fiercely protects the invariant structure. It acts as the boss, controlling the order of operations and making sure nobody messes up the overarching process. Meanwhile, the concrete class handles all the variant implementations. It doesn't care at all about the big picture layout, it just knows it has to provide a specific piece of logic when it's called upon. By splitting these concerns, you completely eliminate the need to duplicate your core structure.
Let's move to Section 3 and see how this actually builds into the real world: framework applications and hooks. Honestly, you might be using this pattern every single day without even realizing it, especially if you work in modern web frameworks.
A fantastic example of this, in the wild, is the active record lifecycle in Ruby on Rails. Think about what actually happens under the hood when you tell a database record to save. It's not just one tiny action. It is a massive template algorithm with strict, predefined steps. The framework runs a before-save check, then a validate check, then it executes the real database query, and finally, it triggers an after-save action. The overarching framework defines that entire strict lifecycle. When you're creating a user model or a blog post model, you aren't writing that complex save algorithm from scratch. You're just inheriting it.
But wait, how do you inject your own custom behavior into a strict lifecycle like that? That is exactly where hooks come in. Now, primitive operations are mandatory. You have to provide them or the code won't compile. But hooks? Hooks are totally optional. The abstract class provides a hook with just an empty default implementation. It's basically the framework saying, hey, I'm about to run the before save step. If you have anything you want to do it now. Otherwise, I'm just going to keep moving. This is brilliant because it lets subclasses safely inject custom behavior. Say your user model needs to strip empty spaces from a username before saving. You just use the before save hook. The main template method keeps ticking along perfectly, and you've safely injected your custom logic without breaking a thing.
All right, Section 4, the Hollywood Principle. Behind all this clever architecture is a really fascinating philosophical rule of software design.
Don't call us, we'll call you. We've all heard that cliché, right? It represents a concept known as inversion of control, often called the Hollywood Principle. Think of an actor auditioning for a huge movie. The casting director says, don't call us, we'll call you. In the template method pattern, your abstract base class is Hollywood. The subclass is the actor. The subclass doesn't dictate the flow of the program at all. It simply provides its specialized little methods and waits passively. The high-level abstract class retains absolute power over when those subclass methods actually get executed. It's a total inversion of control that guarantees your core algorithm remains completely stable.
Moving into Section 5, Template Method versus Strategy. As we wrap up this explainer, we really need to address a major point of confusion for a lot of developers, which is how this pattern differs from its very close cousin, the strategy pattern. When you put them side by side, it's pretty revealing. Both of these patterns exist to help you change how an algorithm behaves, but they go about it in fundamentally different ways. The template method relies heavily on inheritance. It keeps the overarching structure locked in place and only lets you swap out specific internal steps. The strategy pattern, on the other hand, relies on composition. It allows you to swap out the entire algorithm on the fly at runtime. Now, a lot of modern software design definitely favors composition over inheritance, mostly because inheritance can accidentally lock you into a really rigid structure. However, the template method shines specifically when you absolutely must enforce a sequential structure that no subclass is ever allowed to break. If your order of operations is sacred, the template method is for sure your best friend.
And honestly, this just brilliantly illustrates one of the holy grails of object-oriented design, the open/closed principle. Your central algorithm, that abstract class, is closed for modification. You aren't going in there and risking breaking the core logic every time a client asks for a tiny tweak. But it is completely open for extension. By just spinning up new subclasses, you can endlessly expand the capabilities of your software without ever touching that fragile core. It's a real game changer.
So what does this all mean for us? We've gone from a poster printing agency to Rails life cycles and even applied the Hollywood principle. You now have a clear, visual map of how the template method isolates the things that change from the things that stay exactly the same. So, here is my challenge to you. Look at your current code base today. Where are you harboring algorithms that look, 90% identical? Is your code base hiding a template just waiting to be unlocked? Go find it, implement this pattern, and watch how much cleaner your architecture becomes. Thanks so much for joining me for this explainer, and until next time.